Okay, so this video is going to be about solving a system of linear equations by graphing. And feel free to pause this video anytime you'd like in order to take notes and if you need more time to process the information. But before you start watching this particular video, be sure that you are comfortable and familiar with graphing, particularly graphing from standard form. Okay, so let's go ahead and begin. So I've got a system of linear equations, which means that I've got a collection of equations that happen to be graphs for lines. And what does it mean? Okay, I'm just going to ask myself, what does it mean to be a solution to an equation? Well, to be a solution to an equation, it means that if I pick values and plug them into that equation has to end up being true. So, for example, let's choose values like x equals 1 and y equals 3. If x is equal to 1, because that's the x coordinate, and if y is equal to 3, then 1 plus 3 equals 4 makes the bottom equation true. And if that's true, then I can say that 1, 3 is a solution to that equation. On the other hand, if I plug in the values 1, 3 into the top equation, it doesn't come out to be true. So if it's not true, then 1, 3 is not a solution to the top equation. The trick in trying to find the solution to a system of linear equations is that whatever values for x and y I pick, it has to be true. The same values of x and y have to be true for the bottom equation and the top equation. So it has to make both equations, not just one or the other, but both of them true at the same time. All right. And you can see that this could be quite a bit of work if you are trying to do this numerically, plugging and chugging in numbers, various types of numbers randomly for x and y into both equations. It might be time consuming. But if you remember from last semester, there is another way to interpret what a solution to an equation is. And you can do that graphically. And graphically, what that means is, if I graph x plus y equals 4, which is a line, and then I plot 1, 3, a point, it should be right on the line, because this is the solution to that equation. And then likewise, if I were to graph this line, I know that this point is not on that line because it's not a solution to the equation. Well, what I'm hoping for in this method is if I graph two lines, these two lines will not be the exact same line and it won't be parallel. These two lines won't be parallel to one another, so they will actually intersect at one point. If they intersect at one point, then that one point, that point of intersection, is on this line, so it's a solution to that equation. And this point will also be on that line, so it's a solution to that equation. Whatever the x, y coordinate of that point is, that will be the solution to our system of equations. So let's go ahead and graph this. I'm going to graph this by intercepts. I've got x plus y equals 4. So to find the x-intercept, I set y equal to 0. When y equals 0, x is equal to 4. So at 1, 2, 3, 4, I've got an x-intercept. I'm going to do the same thing with the y-coordinate, the y-intercept. So if I want to find the y-intercept, I plug in x is equal to 0, y equals 4 when that happens. So I've got an intercept at 1, 2, 3, 4. So my line roughly looks like this. All right. Not perfectly straight, but you get the idea. All right. Let's graph the other line as well. I've got 2x minus 3y equals 18. Same technique. I need to find the x-intercept and the y-intercept. To find the x-intercept, I am going to plug in y equals 0. When I plug in 0 for y, this goes away. I get 2x is equal to 18. So x is equal to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. When I plug in 0 for x, it will give me the y-intercept. So when I plug in 0 for x, this equals 0. Negative 3y is equal to 18 when y is equal to negative 6. So 1, 2, 3, 4, 5, 6. OK. So at this point, I'm going to draw my line through these 2 points. And you can see they actually intersect at a particular point. And the point of intersection is right here. Let's take a look at the coordinates for that point. 1, 2, 3, 4, 5, 6, 1, 2. This is at 6, negative 2. So when x is equal to 6 and y is equal to negative 2, I should have a solution to my system of equations. Meaning that if I plug in x equals 6 and y equals negative 2 into both of these equations, both equations will have a true statement. Let's try it out just to check. I'm going to start off with the bottom equation because that's the easier one. X plus y equals 4. So when x is equal to 6 and y is equal to negative 2, do I get 4? Yes, I do. So that checks off. And now I want to try it for the first equation, the top one. It says 2x minus 3y equals 18. So when x is equal to 6 and y is equal to negative 2, will I get 18? Well, 2 times 6 is 12. Negative 3 times negative 2 is positive 6. And that does indeed equal 18. And that's my solution.